Hi everyone, welcome again to Ask IITians Learning. So, in the previous part of this chapter, Atoms and Molecules, we have discussed about the mole concept. We learned how mole, which was a quantity, can be used on subatomic particles and what are its varied relations with number, mass, and volume of the given particles. So in today's lecture, we'll be continuing with our chapter of atoms and molecules, and we'll be learning some Olympiad level topics. These topics include the application of the mole concept and the limiting reagent concept. Second, we'll be talking about what is empirical formula and molecular formula and how to derive them. So without wasting time, let's move forward towards this learning. Now, the very first thing that we are going to cover today is the empirical formula. The question is, what exactly is empirical formula? So empirical formula is nothing but analytical formula. Empirical means nothing but analytical. So analytical means something which we have analyzed, something which we found using experiments. And on experiments, or after conducting experiments, we found that the atoms present in a particular compound are present in a specific ratio, right? So we know that every molecule is comprised of certain atoms. Now these atoms are actually fixed in number for a particular formula. For instance, when I talk about water, in water, hydrogen is to oxygen is 2:1. So it means in water there are total 3 atoms. Out of the 3 atoms, 2 atoms are exclusively of hydrogen and 1 atom is of oxygen. Now, it doesn't matter from which source you have taken water, whether you have had the water of lake, whether you had the water of ocean, whether you had the water of municipality, whether you are collecting that water in India, Afghanistan, Pakistan, US, China, wherever, the composition of water will always remain the same. That is H2O. Same way, when I talk about another molecule, H2O2. Now, what have I done? I have just changed the relative ratio of atoms of hydrogen and oxygen, right? Previously, I have taken it in 2:1 ratio. This time, I am taking it in 2:2 ratio, right? So the moment I do so, I'll get a completely different compound. So for every compound, the relative number of atoms are fixed. This was also stated by Dalton. The relative atoms are fixed. Now, for those relative atoms, there can be a simple ratio in which these atoms can exist. For instance, for water, whatever is its specific ratio, that is 2:1, even that is its simplest ratio, right? But for hydrogen peroxide, that is H2O2, H2O is present in 2:2 ratio, which can be further simplified as 1:1, right? Now, it is this simplest form or the simple whole number ratio in which the atoms exist in a compound that is your empirical formula or the empirical ratio. So when I rewrite it, it is written as HO. So that is your empirical formula. Whereas the exact number of atoms which exist in a compound, that is your molecular formula. So if I talk about the simple ratio or the whole number ratio, simplest whole number ratio of atoms, that gives you the empirical formula, whereas the actual number will give you the molecular formula. This is the difference between the two. Now, for some molecules, it might be same. It means the empirical formula might be the same as the molecular formula. For instance, in water. So this empirical formula, I can write it as EF. Molecular formula is MF. So I can say that for water, its EF is same as MF. It is the same. But it is not so in all the cases. Right? So we have to determine, or we should know the way to determine both the things. And how will we do that? That is what we are going to learn in this part. So this is a video which you can see, which will tell you how to determine the empirical formula. And we will be first doing it with the help of an example. Right? So let's see the example. Now suppose there is a compound which is comprised of carbon, hydrogen, and oxygen. Suppose there is a compound which is comprised of carbon, hydrogen, and oxygen. Now, in this part, what is given whenever you see these kind of cases, what is given is their percentage. Okay, so what we get is their percentage. So the percentage of carbon is given as 71%. The percentage of hydrogen is given as 12.95, and that of oxygen is given as 15.81. So you have a compound which is comprised of carbon, hydrogen, and oxygen. Now their percentages are given, right? So whenever you have the percentage, it is always out of 100, right? So in your second chapter, you have also done your mass percentage part. So what is mass percentage of any element? It is the mass of that atom divided by total mass into 100. It means how much of that atom is present from a particle or in a particle which is bearing a total mass of 100, right? So with this percentage, can I say that if I consider the total mass of the compound as 100 grams, can I say that 71.93 also refers that it is the carbon is 71.93 grams in that compound, right? Since it is percentage, so if it is 71% out of 100, so if I take 100 grams, so it will be 71.93, right? Now, if it is in grams, so can I say that, so this is the given mass, right? This is your given mass. And this is your atomic mass. So can I say that this gives me the relative number of moles also? Yes. Can it give me the relative number of moles? So I'm saying that I'm having 5.9 moles of carbon present in 1 mole of the compound, right? 12.9 moles of hydrogen present in 1 mole of compound. Okay, or this is the relative number of atoms, which means like, for example, if I have water. So do you remember when we did the questions, we said that in 1 mole of water, or in one, if I'll say that if in 1 molecule of water, I am having 2 atoms of hydrogen. So if I have 1 mole of water, I would have 2 into Avogadro number of atoms of hydrogen. Because 1 mole means Avogadro number of molecules. And 1 molecule has 2 atoms. So Avogadro number of molecules will have 2 into Avogadro number of atoms. Right? So from here, can I say that if I have 1 mole of a compound, it will have 5.9 moles of the atom, or 5.9 into Avogadro number of atoms, right? Same way for hydrogen, same way for oxygen. Now, if I talk about the simplest atomic ratio, in the simplest atomic ratio, so how do you find that? So first thing what we do is, we first convert the percentage, that's always your step 1 to do this part. So we must know the steps to get to the right answer. So step 1 is always convert the given percentage in grams. That's your first step. Step 2 is what? That whatever are the grams, so whatever is the mass, just divide it by the atomic mass of the atom. Okay? To get the relative number of atoms. Now, what is your step 3? Your step 3 is you have to choose the least of all the relative numbers. So if you see the first one, it is 5.9. This is 12.9. This is 0.98. Right? Out of the 3 numbers, which is the smallest? The smallest number is 0.988. Okay. So that is your simplest atomic ratio. So how do you find out the simplest atomic ratio? Just use the relative number of atoms divided by the smallest relative number of atoms. So the relative number of carbon divided by the smallest relative number out of all, which is for oxygen. Same way for hydrogen I do, its relative number divided by the smallest. For hydrogen, divided by the smallest. So, from there I get a number. Okay? It is that number which is the simplest atomic ratio. So, for these, to find out this empirical formula, there is a particular fixed series of steps. The moment you keep on doing these steps, you'll always land up getting your answer, no matter what. Right? So when you get the simplest atomic ratio, so it means in that molecule, there are 6 atoms of carbon, 13 atoms of hydrogen, and 1 atom of oxygen. So this is the simplest whole number ratio of the atoms, and that is why what we have got is the empirical formula and not the molecular formula. We just got the empirical formula. Why? Because we analyzed things. From the experiment, whatever percentages we got, we just analyzed it, doing some mathematical calculations, and from there we landed up to some value, some simplest ratio. So that simplest ratio will lead to the empirical formula and not to the molecular formula, right? So in that case, what should we do to get the molecular formula? So in order to find out that, we need to see that whenever we find out the empirical formula, we can always calculate its mass. That is the empirical formula mass. How will I do so? I will do so by knowing whatever are the simplest ratio of atoms and multiply with their atomic numbers just like we find out the molecular masses. So if I have 6 carbons, so 6 into 12 plus 13 into 1, because 1 is the mass of 1 hydrogen. There are total 13 hydrogens. Same way, we have 1 oxygen and mass of each oxygen is 16. So this will give you what? This will give you the empirical formula mass, right? So that is what? 72 plus 13 plus 16. Right? So this will be 101. Right? So this will be the empirical formula mass. Now, what happens is we can find out the molecular formulas by knowing the actual molecular mass of a species. By knowing the actual molecular mass of a species. Okay. So, suppose okay. So, suppose there is a compound. Now, first of all, you might be having a doubt that how can you find out the actual molecular mass? So, the answer to your question is there is a thing known as mass spectroscopy or mass spectrometry. So, with the help of this instrument and this technique, we can find out the molecular mass of a compound. Okay? With the help of this technique. Now, suppose there is a compound. Let there be a compound. In that compound, there is carbon, hydrogen, and oxygen present in the ratio of 1:2:1. Okay? There is a compound in which the simplest ratio of carbon, hydrogen, and oxygen is 1:2:1. So, its empirical formula will become what? C1H2O1, CH2O will become its empirical formula, right? Now, suppose the molar mass which we found with the help of the mass spectroscopy is 60. The molecular mass was 60. So then, can I find out the molecular formula? So yes, I can. What did it say? It says that you can easily find out the molecular formula by comparing the compound's molecular mass to its empirical formula mass, right? So in order to find out the molecular formula, what we do is we find a ratio of molecular mass is to empirical formula mass. And that ratio we designate as N. It is the ratio of molecular mass by empirical formula mass. Now the molecular mass is given as 60. What is the empirical formula mass? Can I just calculate? Yeah. So empirical formula mass would be the mass of this formula. In this formula, we have 1 carbon atom. So 12 mass. 2 hydrogen atoms. So 2 into the mass is 1. And 1 oxygen atom, the mass is 60. Right? So its total mass would be how much? 16 plus 12 is what? 16 plus 12 plus 2 is 30. 28 plus 2. So this divided by 30 will give you a value of 2. Now, whatever is the ratio, it means this is the factor. This is the factor which, when multiplied by the empirical formula, will give me the molecular formula of the compound. Right? Just like cross multiplication. So empirical formula has come from the empirical formula. So if you multiply it with that factor, you'll get the molecular formula. So let's see here. So the factor was 2 into the empirical formula. Or basically, in the nutshell, I can rewrite this thing as N So I can say that N into empirical formula will give me the molecular formula. Yes. So by putting the values, for N, we can put the value as 2. So 2 into empirical formula. For empirical formula, we will put the value as CH2O. What do we get? C2H4O2. That will be your empirical formula. Oh, my bad. That will be your molecular formula. C2H4O2. That will be your molecular formula. Got it? It can represent another compound known as CH3COOH, which is, the people do not know, this is the formula of vinegar, the common household vinegar that you have. Okay? Also known as acetic acid or ethanoic acid. It has multiple names. Right? Did you understand what is empirical formula, what is molecular formula, what is that relation, how to get that relation? Right? This is again a small video which will help you for the very sake. If you have understood, now let's move to the question. Okay? Which is just to know how much you have understood this. So let's see the question. The question says, the empirical formula of boron hydride is BH3. This is the empirical formula. Calculate the molecular formula when the measured mass of the compound is 27.66. If the measured mass is this, so measured mass of the compound means molecular mass of the compound. And this is your empirical formula. So if you want to find out the molecular formula, we have a very short method. And the expression is this, that molecular formula is N into the empirical formula. Now, this is what we need to find. Empirical formula is already given to me, which is BH3. It is this N which I can find out, and the moment I'll find out this, my complete work is done. Right? So that is the approach. We must first know what, in order to land up to your answer, which formula we must apply. So first we need to find out that. Now, once we know the formula which we need to apply, then we should know which all things are given to me and which all things we have to find out using the question itself. So in this part, molecular formula is the asked thing. Empirical formula is given, and N we can easily find out from the given information, right? So N is what? N is molecular formula by empirical formula. Now molecular formula is already given to me. What is empirical formula? So empirical formula is the mass of the atoms which are present in the empirical formula. So there is one boron atom which is present and 3 hydrogens which are present, right? So one boron is having a mass of 10.81, which is nearly 11. Okay, and the mass of the one hydrogen is 1. So there are total 3 hydrogens. So total mass will be 3 for the hydrogen. Total mass will be 13.8. So what will I do? I'll divide the molecular formula mass by the empirical formula mass, right? I'll get the value of the factor, okay, the ratio of the two things. So that factor I'll just put here and I'll get my molecular formula. So 2 into pH3 means 2. So whenever I multiply any formula with some number, it means each of the following atom, like the variety of atoms, is multiplied with that number. Okay, so there is one variety as boron. Previously it was 1, so it will be twice. 2 borons. Previously the number of hydrogens were 3, so it will be twice again, so 6. So the molecular formula turns out to be B2H6. That is my answer. I hope it's clear, right? Yes, then let's move to another question. Yeah. Now, this is the question for your practice, and we will be solving each and every part. Now, the question says there is a compound which contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. Then, for this compound, its molecular mass is also given. That is 98.96. So now they ask you what are its empirical formula as well as the molecular formula. So they want you to tell both the parts, right? So you know the case. The case is very simple. So there is a particular strategy which we need to work with. Now, what is the strategy? The strategy is, first thing, we write all the elements which are present in the compound. Then we write their percentages in grams, because you remember whatever is the percentage, the first step is to convert the percentage in grams. Second step is what? Divide their mass in grams by the atomic mass to get the relative number of atoms. Now, we get the simplest ratio of atoms. And that we get by using the relative numbers and dividing it by the smallest relative number, right? So let's use this part here. So the elements given are carbon, hydrogen, and chlorine, right? Now the percentage of carbon is given as 24.27. So I'll write that part here. The second step is, so that is in grams, I'll divide this percentage or this grams by the atomic number. So 24.27 divided by 12.01, which is the mass of carbon, to be very precise, right? So this value turns out to be 2.02. This value comes out to be 2.02. Now, again, the percentage of hydrogen is given as 4.07%. So I'll write it here, 4.07. Second step is to divide it by its atomic mass, which is 1.008. To be very precise, you can also take 12 for carbon, 1 for hydrogen. No problems with that. Okay, don't worry. So this value comes out to be 4.04. Same way, let's talk about the percentage of chlorine, which is given as 71.65. So let's put it here, 71.65. Again, I'll do the second step, 71.65 divided by 35.5, which again gives me 2.02. Now, what is the simple value? The simple value is 2.02. So I'll take the relative number of atoms and the smallest is 2.01 or 2.02. So the simplest atom ratio will come out to be 1. For hydrogen case, it comes out to be 2. And for chlorine case, again it comes out to be 1. As a result, the empirical formula would become C1H2Cl1. This is the empirical formula. So this covers the first part of the question, right? This covers the first part of the question where you have to find out the empirical formula. Now the second part of the question is to find out the molecular formula. And what is given? The molar mass is given as 78.96. So can I do the work? I know that N value or N into empirical formula mass is equal to the molecular formula mass, right? So, first of all, I use the value to find out N. What is the molecular formula mass? 98.96, or I can take it as almost 99. Whereas the empirical formula mass will be what? Let's calculate. 12, just for simplification, you can use the manipulations, right? So 12 into 1, because 1 carbon is there, plus 2 into 1, because there are 2 hydrogens and each one is having a mass of 1, and 1 into 35.5, right? So what is the overall mass that turns out to be? It is 14 plus 35.5. Okay, so it will be what? 49.5. Right? 49.5. So this is what? This is nearly 99 itself. This gives me the value of 2. N value is 2. So 2 into the molecular formula. Oh, my bad. 2 into the empirical formula, which is CH2Cl, will give me the molecular formula. So that means C2H4Cl2 will be the molecular formula. And that are your answers. We had to find out 2 things, empirical formula and molecular formula. And finally, we have found both the things. Right? Is it clear up till here? Yes, but that's wonderful. So now let's move to the next concept. So the next concept is to determine the limiting reagents. Now, what exactly do we mean by this term called limiting reagent? See, have you ever made coffee? Yeah? Yes? Okay. No? It's all right. Suppose. So let's say this. Let's state it this way. Okay. Let's say for 1 cup of perfect coffee, okay, I'll tell you about the coffee, the way of coffee which I like. Okay. So I like if I have 1 teaspoon of coffee, okay. So to this 1 teaspoon, I need 2 teaspoons of sugar, properly stirred well. So 1 teaspoon coffee, to that 1 teaspoon, I need 2 teaspoons of sugar and 1 cup milk. So this is the ratio, or this is the combination which I need for my perfect cup of coffee. Okay, properly beaten. This is my cup. Now suppose suddenly there are some friends of mine who came to my home. All right. So, and there are 5 of them. There are 5 of them. I want to make the perfect cup of coffee. I went to the kitchen and I found that I have coffee powder, like I have a complete bottle of coffee powder. Okay, I have 1 bottle of coffee powder. I have a jar of sugar, basically 1 kg of sugar. Let's say 500 grams coffee. Okay, so 500 grams in itself means around 100 teaspoons of coffee. I have 1 kg of sugar in itself means I have nearly 500 teaspoons of sugar. Okay, but I found that I'm only left with 2 cups of milk in my refrigerator. As a result, how many coffees can I make? With these available quantities, how many actual coffee cups can I make? If I do not want any imperfections in my coffee, okay, it's not like I'll give half cups. I'll give complete cups. Okay, so tell me how many actual number of cups can I make? Only 2? That's right. I can make only 2. Right. So, in this part, can I say that I have excess of coffee? I have a lot of coffee than required. I have excess of sugar than required. But it is milk which I had less. Whatever quantity which is least out of multiple reactants or out of multiple ingredients, that ingredient which is present in least quantity or that reactant which is present in least quantity, that becomes your limiting reagent. That is your limiting reagent. Now, whatever is the limiting reagent, now you know that I make 2 cups of milk. If like I make 2 cups of coffee using the 2 cups of milk. Now, for those 2 cups, how many teaspoons of sugar will I be using? So I know that for 1 cup milk, I need 2 teaspoons of sugar. So for 2 cups, I would be needing 4 teaspoons, right? 4 teaspoons are used. Same way, for 1 cup, I need 1 teaspoon of coffee. So for 2 cups, I would be needing 2 teaspoons of coffee, right? As a result, I had 100 teaspoons available. So after using 2 teaspoons, I know that some of the part will still be available. I still have some coffee left with me. I still have some sugar powder which is left with me. But do I have any milk left with me once I make the coffee cups? No, I don't have. So the importance of limiting reagent is that it gets completely exhausted in a reaction. It's completely used up or exhausted in a reaction. Okay, so if I take them as reactants, it gets completely used up. It's not present anymore, right? Whatever the products that you'll be making, now, these all were the reactants, right? And the product is what? Beaten coffee, right? Well, let's call it as coffee powder so that you won't get confused. So that is my product. Okay. Now, how much coffee can I get? I can get only 2 cups coffee because I had 2 cups of milk available. And for 1 cup coffee, I need 1 cup milk. So can I say that your formation of the product completely depends on the amount of the limiting reagent that I'm having? So product formation is carried by limiting reagent. Or the product formation is found out with the help of limiting reagent. Whatever is the quantity of the limiting reagent, the corresponding amount of product will be formed. Okay, whereas all the excess reactants will remain there in the reaction. They will be left out in the reaction. Okay, excess reactants are left unreacted in a reaction, whereas limiting reagent is completely used up in a reaction. I hope this part is clear. Yes? If it is, then let's see it with the help of a reaction. So suppose I have N2 plus H2, which is giving me ammonia. Now, in order to use the limiting reagent concept, you first always have to balance the reaction. That is the most important requirement. Okay, so we discussed about balancing part in the mole concept and in the variant laws. So when we were discussing the law of conservation of mass, we discussed something related to balance. So if you use this balanced equation, okay, so I know in this equation, I have 1 mole of nitrogen, 3 moles of hydrogen, right? So if I'm given with 1 mole of nitrogen and 3 moles of hydrogen, then I can say that nitrogen is the limiting reagent because it is lesser. But suppose I'm given some different quantities. This is the given, this is the actual requirement, right? This is the actual requirement. Now, how do I know this is the actual requirement? That's because after balancing, whatever are the numbers which are written in front of the atoms or molecules, these numbers are known as stoichiometric coefficients. These numbers are known as stoichiometric coefficients, okay, which actually signifies the moles of reactant or product. So it means that since in front of nitrogen the number is 1, it means 1 mole of nitrogen I have. In front of the hydrogen it is written 3. It means 3 hydrogen molecules or 3 hydrogen moles. In front of ammonia it is written 2. It means 2 moles of ammonia, which further signifies that for 1 mole of nitrogen, I need 3 moles of hydrogen to give, because product is ammonia, to give 2 moles of ammonia, right? Now suppose in the reaction I'm given with, or in the question I'm given with, the given values are 0.2 moles of nitrogen I have and 0.2 moles of hydrogen I have. And they asked me how much ammonia will be formed if I have 0.2 moles of nitrogen and 0.2 moles of hydrogen. Now, I know that in the actual reaction, for 1 mole of nitrogen, I need thrice the amount of hydrogen. I need thrice the amount of hydrogen. So it means for 0.2 moles of nitrogen, I would be needing thrice the amount of hydrogen. So for 1 mole, for 1 mole of nitrogen, I need 3 moles of hydrogen. Then for 0.2 mole of nitrogen, I would be needing 3 into 0.2 using the unitary method. It means 0.6 moles of hydrogen are required. But do I have 0.6? No. I am having only 0.2. So required is 0.6. But I'm actually having only 0.2. It means I'm having lesser quantity than required. So it becomes my limiting reagent, because it limits the quantity. It limits the value. So this is my limiting reagent. Whatever is the limiting reagent, apart from the limiting reagent, whatever are the reactants, they all are your excess reactants. So it means nitrogen is an excess and hydrogen is limiting. Now you remember that whatever is the limiting reagent, it is responsible for the product formation, right? So since it is responsible for product formation, therefore I'll say if 3 moles of hydrogen produces 2 moles of ammonia, then if I'm having only 0.2, so they will produce how much? 2 by 3 into 0.2, 0.4 by 3, or 0.166 moles of ammonia. So that much would be my product. Understood? Did you get this properly? Yeah? Okay. If you have, then let's talk about a question based on this. So the question says that CH4 burns an oxygen to give carbon dioxide and water according to this reaction. So this is the reaction as per which methane and oxygen reacts or combines. So when they react to give carbon dioxide and water, and the balanced equation is given, thankfully. So in one experiment, a mixture of 0.25 moles of methane was burned because it's a combustion reaction. Any reaction with oxygen is combustion. Oxygen is a supporter of combustion. You must have done this in grade 8th. So when it is burned in 1.25 moles of oxygen in a steel vessel, so this was done in an experiment. What do you have to do? You have to find out the limiting reagent, if there is any, and calculate the theoretical yield. Now, what do you mean by this? Theoretical yield means the amount of product. The amount of product, that is nothing but the theoretical yield. In moles, you have to calculate for water, right? So these are the given things. This is the thing which we need to find out. Now, first of all, we need to find out the limiting reagent. And we know that it is the limiting reagent which is responsible for the formation of product. And water is one of the products, right? So how to do this? So simply we'll be doing it this way. CH4 plus 2O2 will give you CO2 plus 2 moles of water. 1 mole of methane will react with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. In the given, this is the actual requirement, that is 1:2 ratio. Now, what is the given information or given moles? So I'm given with 0.25 moles of methane and 1.25 moles of oxygen, right? This is the given value. Now I know that I need twice the amount of oxygen for complete reaction. I just need twice the amount. So for 1 mole, I need twice. So for 0.25 moles, for 1 mole of methane, we need 2 moles of oxygen are required. So for 0.25, I would be needing 2 into 0.25, which means 0.5. So this much is required. But how much am I having? If this is the required one, I am having 1.25. So I'm having way more than the required. It means oxygen will become excess because I'm having way more than required. And methane will become limiting reagent because whatever is the other thing, it becomes the limiting reagent. Right? So first of all, I got the answer for the first part. If there is any limiting reagent, you have to specify that, and that is methane. Then you have to tell me the amount of the product formed. So you know that the product is the limiting reagent is responsible for the product formation. So how is it responsible? So as per the equation, what does it say? It says that for 1 mole of methane, since the stoichiometric coefficient is 1, 1 mole of methane produces how much water? 2 moles of water. How are the two things related? So we know that for 1 mole of methane, amount of water produced is 2 mole. right? 2 moles of water are produced. So if I have 0.25 mole of methane, how much water will be produced? Just the twice value. So 2 into 0.25 moles will be produced. That is 0.5. Right? Make sense? Okay. Good. So these two are the answers of the question which was asked. So this was your first answer. And this is your second answer. Right? Now, let's move to another question. So I'm hoping that everyone has noted it down, and moreover, you have the PPTs with you, so you do not have to note anything down. Just need to understand everything, right? Just have to understand it. So let's move to another question, which is, if I have 2.3 grams of sodium metal is transferred to a 3-liter flask filled with chlorine gas, then you have to determine the limiting reagent and the amount of excess reagent present. And you're already given with the masses of sodium and chlorine. Right? So there are two things that you need to find out. One thing is the limiting reagent, and another thing is the amount of excess reagent present in the container. These are the two things that you need to find out. Now, I know the things that you can always relate whenever you're relating multiple things in a question. The best way is to have the comparison which is done on a similar ground, right? You cannot compare two people on different grounds. Like I cannot compare probably Aishwarya's beauty with Sachin's sportsmanship. But these two are completely different cases. And Sachin's sportsmanship with Lata Mangeshkar's singing, or Lata Mangeshkar's singing with Mr. Kalam's intelligence. I cannot do that because everything is having a different ground, different vertex. So as a result, whenever you are comparing two things, they have to be on the same ground. Same way, if you are finding out the excess reagent or the limiting reagent, you can always do so on a similar ground. Now, what is that similar ground? So let's see how to work on it. You remember, whenever you want to solve any question related to mole concept, with respect to a reaction, then you always have to take a balanced equation. Now, since in this, they said that there was sodium metal, which is put in a flask which was containing chlorine gas. So we know that sodium metal is a very reactive metal. It will definitely react with the chlorine gas, which is present in the container. So this is a container. Okay. So this container is already filled with chlorine gas, right? To this container, we transferred sodium metal. Now, sodium being reactive in nature will react with the chlorine gas so present in the flask, right? So as a result, when this sodium reacts with chlorine, it will give you NaCl. And we know that whenever we talk about any reaction in this, we always talk about the balanced equations, always. So what we'll do is balance this equation. And the balancing is very easy. So 2 sodium plus 1 chlorine gives you 2 sodium chloride. Now you remember that the numbers which you write before the atom or molecule in a balanced equation represents the moles. It means that 2 moles of sodium reacts with 1 mole of chlorine to give 2 moles of NaCl. Right? That means these are the actual requirements. So the requirements are in terms of moles. So I can keep the ground same as moles. So whatever the things are given, whether they are given in liters, in particles, and moles, mass, I can just convert everything in one ground or one perspective, and that is in terms of moles. So since I'm given with 2.3 grams of sodium, so I know that in order to find out moles, the formula of moles is given mass by atomic mass. Atomic mass is 23. I'll get the moles of sodium as 0.1. Right? So the actual requirement is 2:1 mole. Now the given values are 0.1 mole for sodium. So for 0.1 moles of sodium, for 2 moles, if I need 1 mole of chlorine, so 0.1 means I will be needing half of it, 2:1 ratio. Right? I would be needing exactly half of the quantity. So using the unitary method, what will I get? It requires 0.05 moles of chlorine. That is the requirement, right? The chlorines required are 0.05. But how many am I having? I'm having 3 liters. So we know that for moles, what is the formula? Given volume by 22.4 liters. So that is giving me 0.1339 moles. I wanted 0.05, I'm having 0.1. Even if I do not see the other decimal places, 0.1339, even if I don't look at that, I wanted 0.05, I'm having at least 0.1. So it means I'm having chlorine in excess. I'm having more than the required value. So whenever, since chlorine is in excess, so whenever one thing is in excess, the other thing will become limiting reagent. As a result, it is given that sodium metal is the limiting reactant or the reagent because these two are your reactants. So you can call it as the limiting reactant also. And NaCl is what? Product. Now the second part, so this is the first part of the answer. What is the limiting reagent? The second part was how much chlorine is left out. Now, if it is in excess, of course, it is not reacted completely. Some part of it remains unreacted or left out. Now, how much is the left out amount? So, for 0.1 mole, if I want sodium to completely react, it will need only 0.05 moles of chlorine. Only. It will only need 0.05 moles of chlorine. And I am having 0.1339. So if it has only used up, this is the total amount, this is the required amount or the used up amount. So how much is left out? what I had initially, initial amount or total amount, minus the used amount or the required amount. That is 0.1339 minus 0.05. So whatever is remaining, that is your remaining amount. That is the left out amount. But he wanted the answer in terms of liters. So how much volume will be taken up by the flask with the remaining amount of chlorine? So what will you do? You know that moles into 22.4 will give you the volume for those many moles. So whatever are the moles, that is 0.0839, I'll multiply it with 22.4 and this is the volume which is left out. Out of 3 liters, 1.88 liters of chlorine is left and remaining has been used up. Right? Understood? So you have to revise the entire thing. The people who have understood, the people who have not. Bacha, of course, this is a little higher level stuff. This is grade 11 level stuff, plus this is Olympiads. So, of course, it will require little more grilling. Okay, and you have to practice a lot of questions based on this to get a grip of it. Okay, please do that. In case of any doubts, you know where to ping. So you can always text me, you can always message me to get your answers if you're stuck anywhere. Okay, so don't feel sad, don't feel bad. If you need any help, I'm always available. All right. So that is all about the entire chapter of atoms and molecules. And after this, we'll be talking about our next chapter, which is the structure of atom. That's all for today, and that's all about this chapter. Please do the exercises. Thank you for learning from Ask IITians. Bye-bye and take care.